If x upon a cos theta plus y upon b sin theta equals to 1 and x upon a sin theta minus y upon b cos theta equals to 1, then x square upon a square plus y square upon b square equals to. See here, we have done a similar problem earlier. What you do is do the whole square. So in I think so 58 number video we have done it. So x upon a the cos theta plus y upon b sin theta the whole square equals to 1. Do a plus b the whole square, that is x square upon a square cos square theta plus 2xy upon ab cos theta sin theta plus y square upon b square sin square theta equals to 1. Equation number 1. Similarly second one, x upon a sin theta minus y upon b cos theta the whole square equals to 1 square. Solve it. X square upon a square sin square theta minus 2xy upon ab sin theta cos theta plus y square upon b square cos square theta equals to 1. Equation number 2. Now 1 and 2, add them. You get, see here, 2xy upon ab sin theta cos theta gets cancelled from both 1 and 2. So what remains? X square upon a square cos square theta and x square upon a square sin square theta. When you add them, you get cos square theta and sin square theta. That will become 1. Similarly for y square upon b square sin square theta plus cos square theta. Same logic, 1. So what remains? X square upon a square plus y square upon b square equals to 2. That is the answer. This is basically the radius equation of a circle. Next, if x sin cube theta plus y cos cube theta equals